Hello! In this video we will look at the relation of wood connections and CNC milling. Joinery is a crucial component in timber construction. Techniques like mortise and tenon, dovetails and lap joints have long been employed to form strong, durable connections between wooden elements. In a half lap joint, half of the beam width is cleared away. When joining the parts, the surfaces are at one level. The joint becomes stable when reinforcing it with screws or sheet metal parts. It is the simplest connection and can be done in a short time. There are different sorts of tenons. A subtenon is chiseled out over the whole width of the beam. The dovetail joint is probably the best known as most complex connection. Because of its form and the many contact surfaces, it is one of the most stable connections. By this connection, two boards meet at their edges at a right angle and are virtually interlaced. A notched housing should have a depth of 1/4 or 1/6 of the beam height. The beam projection requires a length of 8 times the depth of the notch, or at least 20 centimeters. Furthermore, a gap of 3 to 5 mm has to be included. The hooked scarf joint is a very resilient lengthening joint. It can handle both tension and compression forces. These joints are common for the construction of timbered houses. Understanding the forces that affect wood-to-wood connections is vital in determining the right type of joint for a specific application. In timber construction, there are 3 primary forces we need to consider: tension, compression, and shear. Tension force tends to stretch the material. In wood-to-wood connections, tension mainly impacts joints like scarf joint and certain types of doweled joints. Compression forces act in the opposite direction of tension, pushing two objects together. Mortise and tenon joints are highly effective in handling compressive forces. Shear forces act perpendicular to the length of the material and can lead to a sliding failure. Lap joints and dovetail joints are often designed to resist shear forces. In many real-world applications, a joint may experience a combination of these forces. For instance, in a timber-framed building subjected to wind loads, the joints might face both tension and shear. Therefore, understanding the complex interplay of these forces is critical for choosing the right joint type. While wood-to-wood joints have their strengths, they also come with inherent limitations that architects and engineers must consider. One of the most prominent issues is moisture sensitivity. Wood is hygroscopic. It expands and contracts with changes in moisture content. This behavior can compromise the fit and long-term stability of the joint. Specialized coatings or moisture barriers are often needed, especially in environments with significant humidity fluctuations. Biological threats like fungal decay and insect attack are also concerns. Certain wood species are naturally resistant, but many require chemical treatments to prevent decay, particularly when used in outdoor or damp environments. Skilled craftsmanship is often necessary to traditional wood-to-wood joints, making the labor, costs, and time investment significant. CNC milling can alleviate this but comes with its own set of complexities, including programming and operating the machinery. CNC milling allows for extremely tight tolerances. This results in joints that fit together perfectly, leading to increased load-bearing capacities and less reliance on fasteners or adhesives. CNC milling starts with a digital model that is translated into machine code. The milling machine then crafts the wood with sub-millimeter precision. This is especially advantageous for complex joints that would be exceedingly time-consuming or even impossible to produce manually. CNC milling can be costly, particularly for small-scale projects. On the other hand, it can significantly speed up construction and reduce labor costs for large-scale projects. The Tamedia office building in Zurich used CNC milling for its 1,400 prefabricated structural components. The forked ends of the beams slotted around the columns, utilizing an oval-shaped spacer beam for added stability. This allowed for an assembly time of just 3 months on site. To further secure the joints, beech plywood dowels and plates were inserted at the connection points, enhancing transfer strength. CNC milling was pivotal in crafting these complex components with high precision. The Wiki Pavilion in Milton Keynes employed the WikiHouse Skylark 200 system, a modular building solution. CNC milling was used to cut the joints, designed for rapid assembly without the need for fasteners, enabling the structure to be put together in 2 days. The CNC milled joints in the Wiki Pavilion are not just quick to assemble, but are also designed for disassembly and reconfiguration, allowing the structure to be moved or altered with ease. In summary, the world of wood-to-wood connections is rich and ever evolving, especially with the advent of CNC technology. As we proceed, consider the implications of these advancements on both design and sustainability.